Hey everybody, welcome back. Last time we talked, I covered a topic called sequences and just kind of an introduction, looked at sequences of numbers and their sums, so adding those sequences together. Today we're going to look at a particular type of sequence called arithmetic sequences. I'll talk to you about that, about what those look like. Some cool formulas just to find different terms of the sequence, and then finally adding the terms of arithmetic sequences together. So first of all, let's look at what an arithmetic sequence is in a quick example. Basically, the idea is you start off with a term and you add the same amount to each term to get the next term. So you start with a term, you add a number, then you add another number, then you add another number, and so forth. Okay, so just a real basic one. If you start off with your n values, those are your inputs, remember. Let's do 1, 2, 3, 4, 5, and 6. So we get the first 6 terms written out. And then let's say I just wanted to start off with my a sub n, my a sub 1, the first one, being the number 2, and then everything after that is just adding 5. I'm just going to do a plus 5. So if I add 5 to 2, I get 7. If I add 5 to 7, I get 12, then 17, then 22, then 27, and so forth. Okay? Alright, so there's a little table of values. This represents an arithmetic sequence because you're adding the same amount every time you move from one term to the next. Here it's always an addition of 5. Okay? Okay, so if you consider these a sub 1, the first term, a sub 1 must be given. Okay, that's sort of set in stone. There's got to be a starting point. From there, you add what's called the common difference, right? The number that you add each time is called the common difference because it is the difference between consecutive terms, right? 22 minus 17 is 5, 17 minus 12 is 5, and so forth. So it's the common difference, okay? That common difference we're going to call D. D for difference. Okay, so D equals 5 is the common difference. Alright, that also must be given. I mean, it could be found, but those are the two key parts of an arithmetic sequence, is an initial term and a common difference. Alright. So, in general, an arithmetic sequence must be defined recursively. Remember, we talked about recursive definitions last time. Basically, any term, we'll call it the nth term, must be written as the previous term, n minus 1, plus that common difference of d. Okay? So a sub n is a sub n minus 1 plus d. And you can see that from our chart up here. If you think about it, a sub 1 was the number 2. A sub 2, which was the 7, was simply the previous one plus the d. So it was a sub 1 plus our common difference of 5. Right? It's our 2 plus 5, gave us 7. And then the a sub 3, that's our third one here, is the previous one plus 5. So that'd be a sub 2 plus 5, and so forth. And that's how we get this recursive definition. Every number, every term, the nth term, is equal to the n minus first term plus the common difference. Okay. Well, that concept then gives us kind of a slick formula to finding the nth term without having to know the previous term. Okay, let's say I wanted to find the 20th term on this. I wouldn't have to continue with this 20 times. Or if I wanted to find the 500th term, I would not have to continue with this 500 times. There's a short formula, and I'll give you just a brief idea where this formula comes from. Basically, if you think about a sub n equal a sub n minus 1 plus d, the a sub n minus 1 is really a sub n minus 2 plus d. And the a sub n minus 2 is really a sub n minus 3 plus d, and so forth. And so you're always getting the previous number plus d. Well, if you do a substitution, I won't go through all the details. Your book actually does derive this formula for you. But you essentially do a substitution over and over and over again until you get back to a sub 1. And then you do some simplifying of terms and a little bit of algebra to clean it up. What you'll end up with is a real nice formula that says a sub n is equal to the first term plus n minus 1 times the d. Now, what does that mean? Well, if you think about it this way, each time you add a 5, you're adding one less 5 than the term itself. So, for instance, if I wanted to find a sub 6, you could think of it, like we did before, as a sub 5 plus 5, the d, right? D is the 5. Or you could think of it this way. It is a sub 6 equals the first term plus how many 5s? 1, 2, 3, 4, 5 5s. Right? So it's the first term plus 5 5s. 1, 2, 3, 4, 5. The number of 5s, the number of d's, is always going to be one less than the n value. So that's where the n minus 1 comes in. Okay? So that tells us then if I wanted to find the 20th term, I just take the first term, which is 2, and add to that n minus 1 times d, which is 5. Okay? Now n is 20, and the 5 is the d, and the 2 is the a sub 1. And so when I simplify this, it's 2 plus, what's that, 19 times 5. Well, 19 times 5 is 95. 2 times 95, or 2 plus 95 does give us 97. So the 20th term, if I were to write all these out, would end up being the number 97. Okay, so that gives us a really nice formula to finding the nth term. Now you can rearrange these a little bit and you can find other terms if you want, but I'm really just interested in you being able to find the nth term from the first and the d. Okay. Now there is something interesting, one other interesting fact here is that you can, if you're given a strange looking sequence, the question is, can you prove whether it's arithmetic or not? Okay, and to do that, let's say you take, let's say you want to prove that this sequence 3n plus 1 is arithmetic. Okay? Or determine whether it is or not. What we're going to do is we need to show that every two terms that are consecutive have the same difference. So it doesn't matter which two terms I choose, I'm always going to get a common difference. Oh, I'm not pointing at the right thing. I want to show that every two terms that I choose is going to have the same difference. So it doesn't matter which two I choose, I'm always going to get the same difference between them. Okay? Well, I can't just check every option because there's an infinite number of terms. And so instead, what I want to do is pick two general terms that are consecutive. They're next to each other. We're going to call them a sub n and a sub n minus 1. Okay, those are the two terms we're going to use. And so a sub n if I plug in the n, I get 3n plus 1. A sub n minus 1 is just you replace this n with n minus 1. So you get 3 times n minus 1 plus 1. Okay. Alright, so now what I want to do is show that this has a common difference. In other words, the distance between these, or the difference between these, is the same number every time. So if I subtract these two things, this quantity from this one, right? So that's the difference between a sub n and a sub n minus 1. If I subtract those two amounts, I should just get a constant. It could be a number 1, it could be a number 7. Whatever it is, as long as it's just a constant, just a number, then I know I have an arithmetic sequence, because then every consecutive pair has a difference that's constant. So let's go ahead and simplify this thing. Well, I can distribute 3n plus 1. I distribute this, actually I distribute the 3 on the inside here. So I get minus plus 1. Right, that's distributing the 3. And then I'm going to get 3n plus 1 minus, let's call this 3n minus 2 if I combine my terms. Distribute this minus sign. Bring it over here. I get 3n plus 1 minus 3n plus 2, right? The minus distributes to both terms. 3n minus 3n drops out, and I get 1 plus 2, which is 3. Now, if that's a number, and it doesn't involve n, so there's no variable here, that means the difference between any two consecutive terms is this constant 3. And I've done my proof. Okay, as long as that's a constant, the sequence is arithmetic. So I could say 3n plus 1 is arithmetic because consecutive terms have a difference of 3. All right, very good.